Hi, this chapter 8 estimate procedure, which is we want to use formula to estimate what would be the range of the population mean. We'll have 4 questions we want to solve. The first question is, we're going to read together. E8.4. The dean of a university, she wants to use the mean of the random sample to estimate the average amount of time students take to get from one class to the next class. From one class to the next class. How many minutes the student needs. She wants to assert with the probability of 0.95. There will be confidence level 95%. Then her error will be at most 0.25 minutes. The error of margin E equals to 0.25. If she knows from the past studies that the population standard deviation is 15 minutes, we want to find the N for her to validate the study. For this problem, we roughly know that we're going to use the error of margin to find what is the N later on. We need to identify whether this problem fall under the population standard deviation known or population standard deviation unknown. It seems like this one. As such, the standard deviation population is known. We're going to follow the 4 big steps, all related to these 4 big steps. This is a special problem. It's not finding the interval. We want to find what is the sample size, minimum sample size. But it is quite similar. Step 1. What do we want? We want to find what is the sample size required. That is the N to validate this study. Step number 2. What do we have? Let's check at the first item. The sigma we are given. The sigma is here, 15 minutes. The sample average we don't have. The sample size, that is what we want to find later on. The margin of error, the E was given. The E stated here. The error will be 0.25. So E is 0.25 minutes. And then we're going to find what is our N later on. So this problem we need to modify, not following the actual flow. However, we're going to use the margin of error formula to get the minimum N. So we will roughly use the step here, only that at the end, we just using this formula. Let us insert one by one. What do we have? This one we don't know. How about the sigma? Sigma we have 15 minutes. The E we already given. The E is 0.25 here. The ZC is the critical Z-score number. That depends on the questions. The question says that we want to find 0.95 probability that equals to 95%. So 95%, and this problem related to the standard deviation population known. So we're going to use the Z table. When it is known, we're going to use the Z table. So Z table, when 95%, we use the fast way. So equals to this number, 1.96. So it seems that we have everything except for the N. So after we use the algebraic manipulation, we can find our n will be 13829.76. So because we want to know how many students, we need to have integer. Students, we cannot have 0.6 students, 0.76 students, no. Conclusion, at least 13830 students data required to validate this study. Next one. We look at question T8.5. There is one study, and this study carried out to estimate the average weight of SMK JD students. We are not taking from Form 1 to Form 5 students. We just selecting the 15 years old students. So we call up the 15 years old student come. So we know that we have a lot of 15 years old students here as SMK because of the time constraint. So we just select 100 students. And from these 100 students, the population variance is 80 cm. We not given the population standard deviation. We are given the population variance. Suppose the sample mean was 145 cm, and we want to find with 95% confidence interval the mean weight of the students will be between where to where. We know that this problem is trying to estimate the population mean average from where to where. So it falls under our chapter 8 estimate procedure. Now we want to identify whether it belongs to the standard population standard deviation known or unknown. Obviously, we have it. Why? Because there's a statement says that the population variance is like relative to the standard deviation. So now we know that we're going to use the formula from these 4 big steps here. Okay, we're going to follow the 4 big steps. First step is what do we want? We want to find what is the minimum height who SMK yearly student. We choose those 15 years old one. Step number 2. What do we have? Population standard deviation we don't have. However, we have the population variance. Sigma variance is sigma squared 2. It's 80. It seems like, so if we want to convert to the sigma here, so we just set 80. So after setting 80, when we use the calculator, set 80 equals to 8.9. So we have 8.9. Now we have our population standard deviation 8.9. Sample average. Do we have the sample average value? Yes. Here, 145 cm. How about the sample size? Yes, 100 students. Step number 3. Now we want to solve. So we can just follow the same procedure. That is to find our Z-score critical first. This problem, 95% confidence interval. So from the fast way, when the confidence interval equals to 95%, so when we check the table is equals to 1.96, the Z. C. So we have the ZC already, 1.96. How about for the sigma? Sigma is the population standard deviation. Do we have it? Yes, 8.9. How about the N? Yes, we have 100 students. So later on, we can find our E value, the error of margin. E, after the calculation, we get the number is 1.75. E, we're going to replace into the confidence interval formula. Yeah. And then how about the sample average? Do we have this number? Yes. Going up to here, sample average. The number is 145. 145. So replacing the numbers into the intervals. So we get the final conclusion. We are 95% confident that the true population average mean of SMK Jelly student heights lies between 143.2 to 146.73. Next, 8.6. We read the questions. The mean weight for 8 adults male are given as follows. So we have the data here. We're given the data. Construct a 90% confidence interval. Now no longer 95, 90%. To estimate the mean height for all adult males. When we look at the question, there is no population standard deviation. This one we don't have. So we are going to use the package here, which involves the T-score critical. Step number 1, what do we want? We want to find what is the minimum weight of the adults, male adults. Maximum weight of the male adults and the population mean will lie between these two numbers. Step number 2, what do we have? Do we have the sample average? No, we don't have it right now. However, we can sum up these 8 numbers, divide by 8, we can get what is our sample average. Means that at the end, we can get a number here. We want to find the sample standard deviation. Okay, to get the standard deviation is more complicated. So this, do it manually, it takes some time. So later on, we still can get the number here. Sample size, yes, we have 8 adults and equals 8. Margin of error, can we later on come up with a number from the margin of error here? Okay. The first one, we want to find what is our T-score critical for this problem. 90% confidence interval. When we look at the T table, so we can find what is the 90%. Okay, where is the 90%? Okay, we can find where is the 90% here. And then our degree of freedom is 8 minus 1. So it will be 7, it will be here. This will be our TC. Means that for this problem, we're going to have our TC. We're going to have our S. S will require some effort to find it. The n, no problem, n equals to 8. Then we will get the error of margin. After that, we're going to replace our sample average here, the number. Finally, we will have both numbers, the range, and the true population mean will lies between these two numbers. Okay, after the calculation, our S will equals to 5.15. Then the average will be 73 kilogram. Okay, finally, the E will equals to TC is 0.415. This is TC times the S will be here 5.15 divided by cert n is 8. So finally, after the E turns into a number, replaced into the confidence interval, we can come out with the conclusion. We are 90% confidence that the true population weight of the adult male lies between 69.55 kilograms and 76.45 kilograms. Last questions. P8.7. Let's read the questions. The length of 12 fish caught from a lake is given as below here. 12 fish, their length. Assume that the population follows a normal distribution with a variance of 4 cm. We are given the variance now, not the standard deviation. No worry, they are cousins. They are relatives. Now we want to calculate 99% confidence interval to estimate the true mean length of all fishes in that lake. So obviously it falls under the population standard deviation available case. So we're going to use this package. Step number 1, what do we want? We want to find the minimum length of the fishes from the lake. Step number 2, what do we have? Do we have the population standard deviation? Yes, indirectly, because we are given the variance equals to 4 cm. So to find the standard deviation equals to cert 4 equals to 2. Means that we have the population standard deviation equals to 2. Sample average, do we have it? Indirectly, yes. Take some effort, sum up all the length, divide by 12. So we can get our average equals to 10.03 cm. Sample size 12 fishes. Then we want to solve our problem. Find our ZC first. For this problem, 99% confidence interval. Use a fast way, that is the confidence level table here. Find what is 99%. So 99% will be the last one, the last row here, 2.58. Means that ZC we have already 2.58. Sigma, do we have it? Yes. 2. Do we have cert n? Yes. Cert 12. Do we have the sample weight? Yes. Sorry, sample average. We have 10.03. So we're going to plug all the numbers into the confidence interval formula here. We can come out with the conclusion. We are 99% confident that the true population fish from the lake length will lie between 8.54 until 11.5. We have gone through 4 questions. Now it's your turn to just choose one question. Just choose one question. Copy the questions to A4 paper or tablet, solve it, and snap photo, upload to the link here. The link, the link will be something like this. You're going to click which question that you solve, and then upload your question and solutions. Okay, bye bye.